need to make sure this doesn't happen. It's a rare occurrence, but more solar and more cogen makes it more likely, and we just have to be careful with what we do. Of course, there's smart grid solutions. You've seen everyone has their own smart grid slide, but these aren't necessarily cheap. And again, it's sort of a new horizon and a new way for us to look at our system. Different protection schemes, different knowledge, different modeling systems, a lot of information coming into a control room that the operators also have to get used to understanding and managing. So some of the things that we've done to understand and address the increased adoption, we have a website that has solar-specific content. A customer can put their application in online and follow it through as it goes through the process. Projects under 25 kW now go through an expedited process. So on our end, it's just a paper process, and the developer can self-certify. We have training seminars as well. We work closely with NYSERDA and the Department on Building on this. That scary map that you saw this morning from the DOE that showed a very complex set of processes. That was the NYSERDA, DOB, and Con Ed process for a very small, simple PV. And I think as you probably heard me say before, it was scary. It was very scary to see that, but it was even scarier when we didn't know what that process was. So ongoing process streamlining, education with developers as they come in to understand what our requirements are, and trying to understand internally really what do our requirements need to be. I'll hand it over now. Terry, you next? Okay, thanks.
Can we do one question first? I'd understood, I've been telling the world that I've never heard of a solar system actually causing a blackout or a system failure ever in a DG configuration. But I thought I understood you just say just now that has happened where something caused a localized blackout in your system.
Yeah.
Could you elaborate on that?
Yeah, we did have an issue in what we call the fringe of the network, where there are fewer feeders going out to that area. And again, it was a lightly loaded. It was an afternoon on the weekend, and those transformers had been originally set up for heavy manufacturing. Those buildings were now warehouses without a lot of load. So the transformers don't have a lot of power going through them. So it doesn't take much coming backwards to operate those networks.
And so it did actually fail.
Operate them. Yeah.
Okay.
So we had to make some changes out. A few other times we've actually anticipated those, and the developer paid for some upgrades to the system, and it was still made sense for the customer to do.
Thank you, Mark.
Well, good afternoon. I'm Terry Sobolewski. I'm with National Grid. Just a little bit of background on myself. I'm actually relatively new to the company. I've been with National Grid since August. Previously, I was with SunPower for 2 years, doing business development, policy, and project development work on the East Coast. So what I'd like to do just briefly is comment a little bit on National Grid, some of the things that we're doing right now with respect to interconnection and some of the opportunities and challenges that we see going forward as we attempt to address this question of balance of system costs. So just a few things on National Grid. An easy way to remember a few key facts about National Grid is that it's a company of halves. We are actually a UK-owned company, but half of our revenues are derived from our US operations, which are all in the Northeast. We have about 7 million customers in the US. About half of those are gas, about half are electric. About half of our assets are in transmission. The other half are in distribution, over 120,000 miles of pipes and wires across the territories that you see here. We do operate in 3 states, but of course we don't cover all of those states. We share those geographic areas with a number of other utilities in each of the jurisdictions. The one exception probably being Rhode Island, where we do have nearly all the state for both gas and electric distribution. Obviously interconnection is critically important to us. We take it very seriously. But I think it's worth pointing out that interconnection is really part of a broader picture for us. Across our 3 different jurisdictions, we do right now administer about $450 million a year worth of energy efficiency programs. That's funding through SBC, that we provide back to customers in the form of incentives or other programs. Those programs last year contributed about 868,000 megawatt hours of savings and about 22 million therms. And all that went to benefit about 1.8 million customers. So if you do the math, 1.8 million out of about 7 million total. The energy efficiency side of our business is very substantial. Renewables is the other part of what my group manages. So I should have said at the beginning, I cover our customer sales and program operations teams across all of those jurisdictions. And that is inclusive of the energy efficiency piece, but also DG interconnection, gas interconnections and services as well. So on renewables, solar and wind are at the top of the list in terms of activity. On the customer side, we've interconnected about 116 megawatts to date. We've got about 700 megawatts currently in process in varying stages of our interconnection application pipeline. On the utility side, we've actually built about 5 megawatts ourselves. All that's in Massachusetts. We did just recently get approval or an extension on our approval to develop more. We'll see if the company takes the opportunity to do that. We have also contracted for over 300 megawatts of renewables in primarily 2 jurisdictions, mostly in Massachusetts and Rhode Island, and a big chunk of that is the Cape Wind project. Beyond energy efficiency and renewables, we also have a pretty strong focus on innovation, and we've been working very hard across my group and a colleague of mine, Ed White, his group, to pursue what we believe are critically important technologies for customers. So, of course, smart grid, we've got a pilot that we've just launched, received regulatory approval for in Worcester. We are pursuing alternative fuel vehicles. In fact, we do quite a bit of this in conjunction with our natural gas distribution work. And NGVs, we have also deployed about 30 EV charging stations now in the metro Boston area. And we're also exploring what we're calling E-zones. This is where we take large, typically institutional type customers and try to enter into much more strategic engagements with them. Right now we're working with Buffalo Niagara Medical Campus, where we're implementing essentially a whole host of different solutions to support that campus, including EV charging stations, solar, a new energy efficiency model home, which is going to be available to residents to come see what kinds of solutions they can avail themselves of and what the different incentives are in New York State to support those. So again, interconnection is critical, but it is a piece of this broader picture. On PV standards and interconnection specifically, I just thought I'd comment on a few things that we have done to date. We've been really focusing quite a bit on outreach and education. One of the things that we recognized that was creating inefficiency in the process was the ambiguity of the process or the lack of transparency of the process. And so what that created was churn. Folks would come in, their application wouldn't be correct or wouldn't be complete, not necessarily even through any fault of their own, they just may not have been aware of the requirement. And so we've worked hard to get back out in front of stakeholders, developers, customers, to help them understand what those processes are, how they operate, and what the best way is to work through those effectively. Including that, we've done this across our entire territory, but specific to New York, we've held sessions in Buffalo, Syracuse, and Albany, where we've invited those stakeholders in and had our team, our DG interconnection team there to answer questions, our engineers as well, to talk through different aspects of the process. We have tried to standardize our procedures as much as possible and again make them transparent. We've posted an engineering standards bulletin. We introduced it in New York in 2011 and Massachusetts in 2012. Again, it's available on our website. It articulates our processes in quite a bit of detail. And then we also provided, because that was perhaps a little bit too much detail, a simplified process guide to again hopefully expedite folks through the process. And then lastly, on technical innovation, there are a couple of different things that we're working on, but the 2 I thought I would profile, and I believe some other folks are going to mention these as well. First, we have a project in Everett, Massachusetts, where we've got a 600 kW PV array. We've set it up. We've not yet received the storage yet, but we've set it up for a large zinc bromide flow battery to be coupled with that and to effectively demonstrate and test the ability to firm solar with battery storage. The other thing we've done, which speaks directly to interconnection costs, is we've begun a feasibility analysis for power line carrier pulse technology as an alternative to DTT or direct transfer trip. One of the things we've gotten a lot of feedback from customers on is that when we require DTT, it creates a substantial amount of incremental cost in the project. Again, I'm not an engineer, but the simple explanation of these 2 technologies is that direct transfer trip is a one-line communication, one point to one point, requiring a receiver on the other end that allows us to trip off the generator in the event that we have a fault or an outage. associated with that has a certain amount of expense. PLC is more of a broadcast type of technology. We can send the signal down the line itself. The equipment required to receive and respond to that signal is a little bit different and less expensive, and that's one of the technologies we're utilizing to hopefully reduce costs of interconnection. So looking ahead, I think that there are an awful lot of opportunities and challenges both. I think one thing I would just say, I'm not going to go through all of these, but I would comment, number one, to say that what I've observed in many cases, both working within the solar industry and now working within the utility, is that the debate tends to focus on the extremes. It tends to go to either pole. What I've seen in my time is that really there's a great deal of opportunity for collaboration and for compromise in the middle. So we tend to talk about getting all projects, their interconnection timelines down to 2 or 3 days or 10 days.